Hi guys, this is Mr. Tan, and today we're looking at the data analysis or business research or market research. And really, in the past, you guys have used SurveyMonkey and other tools, but you haven't really calculated these for yourself. So what I'm going to do is I'm going to go straight into an example in terms of a table example of data that you might collect and look at how we can calculate the mean, the variance, and the standard deviation. And then later on, I'm going to go back in to explain these in more detail. So we're going to get straight into it and see where we go. And then I'm going to tell you later and we go over all this again. Okay. So let's look at a possible table that you might get. And so bearing in mind that we're trying to work out the mean, the average, the variance and the standard deviation. So we're going to be working these out. So imagine this is a table and you have a question and you have a range of different amounts. So we can see these signs here. So these signs, if we look at these signs, so this sign here means greater than. And there should be a sign, and this one means less than, but then if you have another sign underneath, which it should be another sign underneath these like this. So now this sign here with the red line underneath becomes less than £25 or equal to. So this sign here means greater than £5, so it can be £5 and a penny, but not £5. Or and this sign here where it says, where you've got the arrow below £15 and then the red line underneath means less than or equal to. So we need to bear these things in mind. So if we're trying to calculate the mean, the first thing that we want to try and do is to get the midpoints between 5 and 10, and we're going to round these figures up to the nearest figure. But bearing in mind, this could have been price ranges for a meal, for example, how much people pay or expect to pay when they go out or spend when they go out, and these could be the price ranges that, for instance, you tabulate your responses. And your frequency rate here, your frequency rate are, you know, how many respondents or the people that you interviewed said between 5 and 10, or 5 people said between 10 and 15, 7 between 15 and 20, and 5 between 20 and 25, and 11 £25 and above. So we know that automatically now this 11 is the most frequently occurring, and this is called the mode. And again, we're going to go into what the mode is again later on. So the mode is the most frequency occurring, but in terms of this table, we can see that the mode is the most frequently occurring, which shows the £25 and above. So going back to completing this table to work out the mean, the average within a table format in terms of tabulation and frequency in terms of the data you've collected from your interviews, we need to first work out the midpoint. So let's now go on and work out the midpoint. Now let's move on from here. So here now we can see the midpoints, which we rounded up between 5 and 10 is 8, 10 to 15 is 13, 15 to 20 is 18, 20 to 25 is 23, and 25 and above we've got is 28. And what we're going to do is we're going to fill this table out. So the frequency, again, we've got the frequency here, so the sum of the frequency, sum of f, is equal to 30. So we add all these up, this comes to 30. and later on we can use this to work out the median, the middle. So now we continue working out the table. So the next table or the column that we complete is the f, which is the frequency, times x, the midpoint. So it will be, 8 times 2, 13 times 5, 18 times 7, 23 times 5, 28 times 11. So now we can see we're moving along the table. So let's do that. So now we've completed, the frequency times x, fx, in this table here. And after we've done f times x, we now do x squared. So x times 2, so x is here, and if we square x, we get 64. But at the same time, in f times x, if we sum up the total for f times x, the frequency times the midpoint, we get 630. So now in the table, if you can remember, we started off with the amount and we started off with the frequency. Then we created the midpoint. Then we completed the data on the frequency times the midpoint. 8 times 2, for example, is 16. And then the next column we completed was x squared. So x squared, so 8 times 8 is 64, 13 times 13 is 169, and so on and so forth. And then the next column that we need to complete is f. So you got x squared here, and then you're going to times it by the frequency. So you're going to times it by the frequency. Okay. So you're going to multiply that by the frequency, which will lead into this column here. So frequency times x squared. So let's have a look at this column now if we complete that. So now we've done f times x, which gives us this x squared was 64 in this box, for instance, times by the frequency, which was here 2, gives you 128 here. And likewise we complete the rest. 169 times should be 13. It says 159 there, but it should be 169, and then 324. Slight miscalculation here. That should be 169 times 5, and 324 times 7, 529 times 5, and 784 times 11. And if you sum these up with the adjustment, you come to approximately 14,510. Now, so let's work out. So we've got all the data here. So the data in these columns allows us now to calculate the mean, the variance, and the standard deviation. We've already identified the mode, which is 11 respondents in the £25 plus and above. We can always work at the median, which I'm going to show you. So if we look at the mean, then the mean is the sum of the frequency times the midpoint. So the sum here of the frequency times the midpoint. So the sum of the frequency times the midpoint divided by again the sum of the frequency, which is 30. So if we do 630 as we did, and we divide that by 30, that equals 21. Okay, So that equals 21, and that is the mean, that is the average. That is the average amount of money from these respondents who have selected this frequency are spending. So on average, you know, whatever this question was, if they were spending money, people were spending around £21. So we know the average. We also know the mode. The mode here is the most frequently occurring, which is 11. So that again, that is the mode. And if we was to work out the median, the middle number, what is the middle number that people are spending, then we take the sum of the frequency, which is 30. We add 1 and we divide by 2, so it gives you equals 15.5 pounds. So the middle amount that people are spending is £15.50. So now already with this table we've been able to establish the mode, which is the most frequently occurring, which is 11 respondents of £25 and above. We've established the median, which is £15.50, which is the total frequency, which is 30 plus 1 divided by 2 gives you £15.50. And we've also worked out the mean, the average amount of money. If this was a question about how much people were spending, how much money people were spending as regards to this example here, which was £21, and that was calculated by the frequency times the midpoint total divided by the total frequency. So 630 divided by 30 gives you 21. Now we have to work out the variance, the maximum amount, the range, or the maximum amount that people will spend. So to work out the variance, the total range, then we take the sum of frequency times x squared. So the sum of the frequency times x squared gave us approximately, I haven't made the adjustment for the error in there, so gave us approximately 14,510. Now 14,510 you divide by the total frequency amount, which gives you an amount of £483.70, and then you square the mean. You square the mean, and that comes to £441, and you take away the difference between the sum of the frequency times x squared divided by the total frequency, which gave us 483, minus the mean squared, which is 441, gives us £42 and 70 pence. So this gives us £42 and 70 pence, approximately £43. So we know that if this was people spending in a particular shop, then we know that the average people are spending is £21. The maximum range that people are going to spend is going to be maximum £43. So how does that help us? That helps us because the possibilities of increasing the price to what we could increase the price to, perhaps the maximum, if we wanted to go that far. But we have to also remember supply and demand. So we know that fact. So now we worked out the mode, which is the most frequently occurring. We worked out the median. The median is the middle amount of money being spent. We worked out the mean, the average amount of money being spent, which was £21. We worked out the variance in terms of the maximum range of about £43. Now we have to work out the standard deviation. The standard deviation is a deviation approximate that will deviate from the mean. So, in the mean, what percentage of people will actually deviate from the mean? So, and what price would that be? So in terms of the deviation now, standard deviation, deviating from the average, what amount would that be where people would deviate from the average? So to work this out, all we do is we take the 43 and we take the square root of 43. So we already have 43 here, which we worked out as the variance. And this variance here, to calculate the standard deviation, we simply take the square root of the variation, which gives us in this example £6.56. So we know that if the mean is £21, we know that there may be a standard deviation plus or minus this in terms of £6.56 minus £21 or plus £21. So this helps us in terms of looking at the data. But the good thing here is, with this, completing this table allows you to calculate a range of different things. It allows you to calculate the mode, the most frequently occurring, in this example, how the data and the information has been grouped by the amounts and the categories, as 11 in this example, spending £25 and above. We know that we've calculated the median here, number 2. The middle amount, which was £15.50. We know that in here, number 3, we've calculated the mean, the average amount of money in this example people were spending. We know the number 4 here, the maximum amount of money that people would probably spend in this example would be £43. And we know that the amount of deviation from the average, plus or minus either way, will be a difference of £6 56 and this information will allow you then to make various interpretations in terms of and decisions as regards to what's happening. So it's important to know how to calculate these things, and it's important to understand that we calculate it from this table here. So we're going to move forward now. We're going to go into a little bit more detail in terms of these, but I wanted to go straight into here. So as I've said, that this information is to create information for decision making by summarising data using representative values and analyse the results to draw valid conclusions in a business context. So again, the mean is the arithmetic mean, or average, is the sum of the values divided by the number of data points, or total number of items. The median, the middle, is the midpoint of the data when the data is arranged in ascending or descending order. It's the midpoint between ascending or descending data. The mode is the most frequently occurring value, as we've said before. The range, this is the variance between the upper and lower limits of a particular scale. The frequency is the number of times each value occurs, denoted by the letter F, which is how many times your respondents or people that you've interviewed have actually stated that they belong to that category. If it's qualitative data, then they may belong to that theme. Cumulative frequency, this is the total frequency in a frequency distribution chart. So again, we looked at the variation and standard deviation. Okay, so now let's go forward. Symbols, again, we looked at this, and this first sign here means greater than. Now this sign here means greater than or equal to. This sign here, next one, means less than. This next one here means less than or equal to. And this sign here means the sum of, so the total sum or summation of. And F here stands for frequency. So again, when we normally get data, data can be ungrouped or grouped. So if we look at the frequency of data in terms of it being ungrouped, so this could be an example here, different data here, different data which has been ungrouped. But now, if we go down, we actually group them between 18 and 20 years, between 21 and 23, between 24 and 26, and then we get the number of times people have actually stated here, what their ages were within these grouped ranges. And so this is the data in terms of your tables that you're normally going to get. And when you get your data, then from this table here, you can work out the mean, the variation, the standard deviation, the mode, and the median. But you need to produce a table. And as we previously discussed, the first thing we're going to do is lay the table out. We're going to lay the table out, and we can do the calculations. And I know that there are a lot of software out there, but you should know how the calculations are worked out. So the first thing you do is create x, which it will be the midpoint, and then you will create the next column, which will be f times x. F times x will give you the summation, the total sum, divided by the total sum of the frequency, which will give you the mean. Okay, the next column there will be x squared, and then the final column, as we looked before, will be the frequency times x squared and the summation of that. So again, you can go back and look at that. So again, we have another example here. The following data are the ages of 15 girls in a dance class. You can present this data in terms of grouped information, because it's not going to be much good to you if it's not grouped. So you're going to need to group it and provide frequencies for those groups, and then you can work out all the appropriate calculations. So again, we said the mode is an average which indicates the most frequently occurring value. So in this example here, in example 1, we can see that the most frequently occurring was 6 cars in day 2. So that was the most frequently occurring. So that's pretty straightforward. Finding the mode in a grouped frequency, again, what is the highest frequency between this daily demand? Can you see? Yeah, it's obviously the most highest frequency is 8, and it belongs to this group here, greater than 6 to 10. Okay, so it's greater than 6, so it could be 601. Okay, but not 6. It's a bit greater than 6. Okay, so here we can see an example of the mode in a grouped frequency table. And here again, items bought in different days. We can see the table here demonstrates that this one here, number 1, has the highest frequency. So again, we know the number of items that appeared in most is 8 units, highest frequency, which were bought between 5 to 10 days. We can find out the actual day these items were bought from the graph as shown above. Okay. However, if you say that 8 items were bought on the 8th day, or 8 items were bought between the 5th and the 10th day, then they are both correct. But 8 items on the 8th day is more specific than and accurate than thereafter. Okay, so we need to be very specific. Hence the reason why we've got these signs here. Again, if we look at these signs, greater than 5 but equal to or less than 10. Okay, and it's important to be able to understand and read these little signs that are denoted along here. The example of the median, the middle number, again with ungrouped data, if we take this on group data here, we have to first rearrange this data in terms of, from high to low or from low to high, either or. And then we find the middle number. So we know that the middle number here is 9. That is the middle. 1, 2, 3, 4 on this side. 1, 2. So there's, there's 4 here, and there's 4 numbers here, and number 9 is, the middle. Okay, so we can see that's the median. The median is the middle number. But we also need to remember that we are going to be working in tables, and we're going to be grouping data together and frequencies together. So as we explained in the first example, when we went straight into the tables, the median is calculated by the sum of the total frequency. So here is the sum, which represents 3 plus 7 plus 12 plus 8 plus 5 gives us 35. So the sum, so that's the sign of the sum of the total frequency plus 1 divided by 2. So we know that the median in terms of the frequency grouped table is equal to the 18th item. Because remember, when you are doing your questionnaires, you're going to be putting them to groups, and then people are going to be responding to those groups. So now, again, let's just touch on the variation, the variance, and standard deviation. So the variation, can be present in dataset, and it is used to measure how the values cluster around the mean. And the variance is also used to compare two datasets, such as the mean and median. The standard deviation is the most commonly used measure of variability. It measures the distance from any point in the dataset to the center, the median or mean. This can be calculated from the mean, means absolute deviation, also mean deviation, and variance. The mean absolute deviation or mean deviation is the average of the deviations in individual observations from the mean. This is simply the addition of the variance to the mean divided by the number of observation of frequency. So the standard deviation is the square root of variance, which reduces the variance to the same units as the original dataset. The standard deviation provides insight into the number of observations that lie within any number of standard deviation from the mean. Now, what is really important is two things: is to understand what we're saying and to understand how we calculate this. So, what we are saying is, what is the mean? The mean is the average. What is the variance? The variance is the maximum, distance that it would be, from the mean. Either way. And then we're saying the standard deviation is the deviation we can expect from the average, from the mean. Either way, plus or minus standard deviation. And that will enable you to make business decisions in terms of people's purchasing, in terms of people's spending, in terms of what people are doing from a statistical perspective. Okay, so hope that has reinforced it. Now, mean, deviation and variance. Again, we looked at this. We went straight into it before. So you calculate the mean. You calculate the midpoints. Once you've done the midpoints, you take the midpoint, which is x times f, the total frequency, and you also take the total f times x. So the sum of the total f times x divided by the sum of the total frequency will give you the average, the mean. So let's have a look. So as we said, this is the first thing that we did. We said you find the midpoints. We know that we had we started off with this, and we grouped the data, and we had this. We then created number one, the midpoints. We then calculated number two, which is f times x. We then summed up sum of frequency and then summed up f times x, and all we've done is divided by the sum of fx divided by the sum of f gives us, in this instance, an average of 21. And then to get the variance, all we've done is we've done, x squared, which is the midpoint squared, which took us to column number 3, and then we progressed on to column 4, where we calculated the frequency times x squared, and we summed up the total, gave us this figure here. Now this figure divided by 30 gave us a figure of 483, and then we minus it by 21 squared. So we had the mean, which was 21. We squared the mean, which gave us 441, and that gave us approximately 43. Once we take away the 483 minus the 441, which gave us 43, and then to work out the standard deviation, we take the square root of 43, which gives us a figure of approximately 6.56. So 6.56. Okay, so we know that again, this figure here, the standard deviation, deviates by £6.56 from the average of £21. So this helps us to be able to review, in this instance, if it was pricing and people's buying behavior, in terms of the maximum, in terms of what we could move these to. So this is very helpful from a business perspective to increase potential gross profit margins by increasing sales. Okay, so thank you for that so far, but there's one thing else I want to look at, and that is the correlation of coefficient. Now, what is the correlation of coefficient? Well, the correlation of coefficient is used to quantify the strength of the relationship between two ranked or quantifiable variables. So you're trying to find out what is the degree of relationship between two variables. If you affect this, how is that going to affect this? So this will show you whether a change in one variable is accompanied by a change in another variable or correlation. So the coefficient represented by the letter R can take any value between -1 and +1. A value of +1 represents a perfect positive correlation, so that has a direct influence. Whatever you do here is going to affect this other variable, which means that the two variables are perfectly related, and as one value, variable increases, values of the other variable will increase. Increase in age and corresponding increasing in height during a developmental stage of human growth, for example. On the other hand, a value of -1 represents a perfect negative correlation, which means that the two variables are precisely related. As the values of one increase, the others decrease. An example of this, could be the price, could be an increase in price and a decrease in quantity demanded. So here we can see the scale here in terms of the correlation coefficient standing between +1 and -1, represent weaker positive and negative correlation as shown below. Okay, so the closer it gets to 1, is the weaker the positive or negative correlation. The further it goes out to -1 or to +1, the stronger the negative or positive correlation between the two variables. Okay, so let's take an example of how to calculate this. Now, Obviously, you're going to look at the calculation and you're going to get a bit scared, but don't. You need to just break it down, and you just need to do the tables. If you follow calculating the information in the tables, then you'll be okay. And then you just slot the data into the tables. So here we've got we've got x and y variables. The x variable is going to be the x variable, and that's going to be the price of food. And the y variable, so the y variable is going to be daily customers. So you've got the price of food and you've got daily customers. So we're just going to put this into a table first. So don't be scared of the calculation. Let's just work out x and y. All we're going to do is we're going to do x times y. So we're going to have so the tables we're going to have are x, we're going to have y, we're going to have x times y, and we're going to have x squared, and we're going to have y squared, and that's it. I mean, we're going to have just 5 columns of information, and all you need to do is to just complete the data in terms of day 1, 2, 3, 4, and 5. So we already know x and y because x, because x is all here and y is over here. So we would already have the data for the 2 columns already. So we just need to do x times y, and then x squared, and then y squared. So let's have a look at that. So if we have a look at the tables and we do the sum, so here we can see we already had this data. So we already had number 1 and we already had 2, which was x and y. And now we've done x times y, and we've done x squared and y squared. The formula is here. Now the formula looks a little bit complicated, but when you look at it closely, you'll see that it's not actually that complicated. You just need to break it down bit by bit, just component by component. This component here is saying the number times the sum of x, y. So you take x times y, the sum of x and y, so the sum of x by the sum of y times by the number. The number are 1, 2, 3, 4, 5. There's 5. There's 1, 2, 3, 4, and 5. So here we can see that this is pretty straightforward. Then this is minus, so we do these two first. So the sum of x, well, the sum of x is 113, and times by the sum of y, which is 265. So that's straightforward. And all you do, you times 113 times 265. Obviously you do number times x times y, and you take that away from these two, and that gives you your top figure. If we're working at the bottom figure, so now we are looking at the bottom data, and we're saying, well, we take the sum of x squared. So the sum of x squared is here. The sum of x squared is here. So we know it's 2631, and we minus it, and we take this away from the sum of x. The sum of x is here. So if we take 2631, minus from 113, and then times by the number here, which is 5 rows, then that gives us an answer. And then, and then we do the same for the y. We take, y squared minus y, the sum of y, and we times it by the number, and then all of the bottom we do the square root. So we do the square root of each of these, and this will give us a figure. So let's have a look at the data. So this is not complicated to work this out. If you look at the formula and you break it down, you will see that the sums, on this column here, gives you all the information to put. You just need to put the information in and then calculate the data. So the data comes here, so we can see that if we take x and y, the sum of xy, well, the sum of xy is 50928, okay, times by the number is 5. So again, you can see 5928 times by the number of rows, which is 5. You just put the data in, minus the sum of x times sum of y. So the sum of x times sum of y gives you data. So this is pretty straightforward because you've got all the calculations from the table, and then you just go down to the bottom. You go down to the bottom here, and you put in the sum of x minus the sum of y. So the sum of x squared. So the sum of x squared, you should see it on the table. Again, this table's not here at the moment. So, and then you minus it from the sum of x squared. Okay. So, and then you times these two, x, by 5, and you do the same for y. So you do the same for y, taking the data from the table that you've already calculated. So this then you break down in terms of doing the calculations. It gives you this calculation here, and then you get the top, and you get the square root of 1283, which gives you the final calculation. It gives you is 305 divided by 1133, and if you divide that to 305 by 1133, it gives you 0.27, which shows on the scale, if you remember, it shows a weak negative correlation. So 0.27, so 0.27. So if you can remember, we said closer to the 0 represented a weak negative. This is minus. Is it plus? Or is it be over here? So if it's 0.27, it'll be over here. So again, it's a positive, weak positive correlation. Okay, and that means that there isn't a very strong relationship between the two variables that were being looked at. But if the figure had gone to about here, then you could say that one factor has a serious implication or effect on the other factor. Now, this is pretty straightforward because all you need to do is to complete the information in the table. So again, all you do is take the two variables. One you classify as an x variable, and one category you classify as a y variable. You times x times y, and then you total all the rows up into a sum of xy. You do the sum of x and the sum of y, and then you just do the same. You do the sum of x squared and the sum of y squared, and then with all the data that you've completed in that table, all you simply do is apply that to the formula which I've given you previously, and then see where your final figure comes out between -1 and +1. So yeah, I hope that has helped today with data analysis. So thank you for your time from Mr. Tan.